this presentation section is going to be on the TREMDrain, which is what we talked a little bit about in the below-grade waterproofing presentation, the membrane presentation, and we're going to cover probably the same stuff in this presentation. I forgot to take that out. We talked about filter fabric. Filter fabric is the fabric that you see on the face of the drainage mat that water gets through to wick it away from the membrane, to wick it away from the wall, the structure. The core strength, as I said, is the compressive strength of those little cones. Depending upon how thick your concrete slab may be, you would require a more or less compressive strength. Flow rate is the amount of water that drains through the drainage system over a certain period of time. Again, PF is that polymeric film. Copper hydroxide is used to inhibit the growth of roots. Perfect example was that conversation that we had earlier where the roots are wreaking havoc on your waterproofing membranes. If you used a drainage mat with copper hydroxide, that should alleviate your concerns. Again, here are the pictures with the filter fabric, the core. Remember, we're measuring the compressive strength of those, and then the polymeric film on the backside. It's hard to see, but you can kind of make out those black circles. That's what fits on the end of the drainage system. Those outlets I was talking about, the universal T and the universal drain outlet. Why do you need drainage on below-grade waterproofing membranes? Because it eliminates that head pressure of water. They protect the waterproofing membrane. It reduces the amount of drainage space because you're not going to use that gravel to fill in that space. You don't have to go off of the building as far. It reduces the weight, the load on the building, because you don't have all of that heavy gravel on the building itself. Here's the example that I showed you in the previous slide of if you have trapped water and a crack develops, you can get water through here. If you have a drainage membrane, whoops, didn't mean to hit that. If you have a drainage membrane, a drainage mat, a drainage material, the water would wick through the drainage to the French drain and out of the system. Belt and suspenders type application. What are the advantages of using TREMDrain over aggregate or gravel? Aggregate was the word I was searching for earlier. TREMDrain provides better drainage than that aggregate or gravel. The TREMDrain products are combined with a protection course. So you may not necessarily need to use a protection course because you can use the drainage system as your protection course. TREMDrain is lighter, thus easier to install, thus cheaper than labor costs of shoveling gravel or aggregate into the area. You get that head-to-toe drainage. As I was saying earlier, some situations where you have gravel, you don't necessarily put gravel up against the whole wall. You'll put it at the base. The TREMDrain you would put along the whole wall, and it would weep into the French drain system. The areas where we would want to use the drainage systems would be when we have below slabs on grade. If we have between slabs or horizontal applications, split slabs, backfilled wall applications, weeping it to the French drain system. This is the first time we've used the word, but blindside wall applications, which we're going to talk a little bit more about this afternoon. Planters. In a planter, you're constantly making a swimming pool out of it because you're constantly watering the plants, right? So you can wick the water to a drain using the drainage system. Or on greenscapes. We call this a multitude of different things. Typically, they're referred to as vegetated roofs. Do you have a different term that you would use down here to describe, Leonardo, what a greenscape is? Green roof, roof garden, something of that nature. What type of TREMDrain is used in an application below slab on grade? That would be the TREMDrain S, and that is because of the higher compression strength. And I have samples that I am happy to pass out. Yes, here's the TREMDrain S. my lovely assistant. Also, you could use the TREMDrain 1000. It has a high compression strength, not as high as the S. However, it does have a better flow capacity, so you can wick more moisture away. And this is the 1000. Pass those out if you don't mind. In relation to the waterproofing, where do you install the TREMDrain in the below-slab application? You have your soil. You have your geotextile fabric. You have your waterproofing membrane that you can apply to your geotextile fabric. It's hard to tell, but that's the waterproofing membrane. It's hard to see in there. And the structural slab. Sorry, I didn't. It should show it in here. Where'd it go? Because this is bonded to this. So it would be just above the waterproofing membrane, right on top of, right below the structural slab. Sorry. What type of TREMDrain is used in a between-slab condition? TREMDrain 1000 with Typar, which is the geotextile fabric, and that is used to eliminate the adhesion of concrete to the drainage membrane itself. TREMDrain 2000 is also used to eliminate the adhesion of concrete to the facer. It has a similar to the geotextile fabric. I only have one sample of this, but I'll pass it out. You can feel it. It's almost like Kevlar. And it's hard to bond to for concrete. TREMDrain 2000 is, like I said, I just passed that out. Or TREMDrain S, that has the highest compressive strength if you have a heavy topping slab. In a between-slab application, you would have your structural concrete, your membrane on your structural concrete. You would have your protection course if you deem it necessary, or you would just VE out the protection course and use the drainage as your protection course, and that would be on top of the membrane, right below the topping slab. Here you can see some pictures. In a backfilled wall application, TREMDrain, no numbers after it, is the most cost-efficient way with a good flow rate and compressive strength. TREMDrain 1000, if you expect to see a higher water flow rate, would be used in that application. And one possibility that's not used very often is TREMDrain QSP. In the backfilled wall application, you have your wall, you have your membrane, you have your protection course, or drain it. The protection course can be eliminated with the drainage, but you could install both there as a belt and suspender system. And then you would put your overburden back on top of it. It's hard to tell in this picture. However, you can see that they do have the drainage up. Underneath the drainage is the waterproofing membrane. In a Blindside application, which I came in on Friday, and I've had the ability to spend some time in the city of Bogota, which, by the way, is an awesome city. But it looks like you don't have a lot of room to excavate back outside of the buildings, so I think you probably are doing quite a bit of Blindside waterproofing here. And that's where you dig a hole, and then you dig a hole to the street or whatever structure you have to stop at, and then you put in steel pilings, and then have a wood lagging wall in between those pilings. And we have this afternoon to discuss the sheet applied products that we would use in that situation. But the drainage you would use in that situation would be TREMDrain is also acceptable. TREMDrain 1000 is also used if you need that higher flow rate. And then the total drain system, that is that original sample that I passed out, where it has really thick cones at the bottom and thinner cones at the top, and you would tie that in along your base to tie into your outlet systems and your French drain system. Here's a detail of how it would work installing it. You would install your drainage down to your outlet pipe to get into your French drain system. Actually, I'm working backwards, I'm sorry. Here's your lagging wall. You would install your drainage. Depending upon how you have your drainage How you have it set up to flow out, you would typically flow it into the hole, is the big hole in the ground that you have in your backfilled situation, blindside situation. And then you would put your paraseal, your sheet applied membrane, over top of the drainage on the inside, and then you would pour your foundation wall up against that paraseal. Here's a better picture of what I was trying to describe. It's hard to see with the light, but the concrete wall is not in yet. But you can see that clay, that lighter material, that is the bentonite from the paraseal product that we'll talk about this afternoon. And you can see that behind that, hanging out over there, is the drainage. What they'll do is they'll put a form over here, and then they will pour the concrete in there, and then they get that compressive strength of the concrete to the bentonite, which provides your secondary waterproofing system there. Here's what I was talking about where I said you could have the drainage in the hole. It would be under your foundation slab in this situation. And this would be sloped downhill to leave the pit to go to a city drain or city sewer or something of that nature. Here's another picture where you can see drainage being installed. In the blindside application, remember, you're pouring a concrete wall on the inside of the building as opposed to working on the outside. So you want that filter fabric to face the lagging wall, to face the outside. And then what you do is you install your paraseal membrane and then pour your concrete over the rebar in that application. And the concrete will give you that compressive strength up against the membrane, the bentonite of the HDP, or the bentonite of the paraseal. Why would you want to use TREMDrain in a planar application? Or what type, I'm sorry. The types that you would use is the TREMDrain GS, TREMDrain 2000, or TREMDrain 3000. The filter fabric can or cannot be treated with the copper hydroxide. The GS has the copper hydroxide. The average compressive strength of the GS increases higher than the 1000, but the 2000 is higher than that, and the 3000 is higher than that. The 1000 is kind of the basis, but the GS, the 2000, and the 3000 are higher. You also have a greater flow capacity too. With the higher compressive strength, you can get more water through there. In a planar application, you can see the drainage is in here because keep in mind you're putting the membrane on the outside of the concrete, and then you're filling the inside of the planer with the water to water plants or whatever that may be. And then you would use the drainage to get you to a drain, which you see down at the base. What type of TREMDrain would you use on a greenscape? You'd want the GS. The GS for a couple different reasons, because it has the larger cups for reservoirs for the plants, so that way the plants can have their roots kind of get close to it or near it to suck up some water, but it also has that root inhibitor too to keep the them from coming through the system. It's also available in different configurations, not just in one roll size, because you have the planer size where they're much smaller than having a typical rolling it out on a slab or doing a backfilled wall. Sometimes you need to have that smaller size, and that's what the TREMDrain GS can accommodate. It's a 1/2 inch. It's used extensively, like I said, for the greenscapes, using it with 2 to 6 inches of growing media on top of it. That's the 1/2 inch GS. The TREMDrain GS at 1 inch, which is the thickness of the cones, is used for if you have a deeper growing media on top of there. It just provides you a higher compressive strength. So that way the load that's sitting on the drainage mat doesn't compress the cones unnecessarily. Both of the TREMDrain GSs are available in a standard or treated fabric, so the copper hydroxide or not. The treated fabric, as I just said, is coated with copper hydroxide, which can stop the roots from permeating through and getting into your structure. In a greenscape application, you have your slab here, and then you would put your waterproofing membrane. You would put your protection course, or you would put the drainage right on top of it. Typically, you would have insulation. Then on top of that, you would apply another layer of the GS, and then have the overburden. The total drain is the sample that we talked about earlier today that I passed out, where it has the thinner cones at the bottom and the thicker cones at the base. It's a ton of water. I did not convert this to metric, but it handles approximately 100 gallons per minute. So that would be 400 liters-ish of water per minute. Is my conversion correct? I'm rounding. So if you think about the amount of water that is in your system, that is a ton of water. It's a non-woven polypropylene filter fabric with a high-profile section that transitions to the different trem drains. So the thinner section at the top, you would snap onto your other trem drain. You would typically use, here's a good example of it, you would typically use it at the base, and then if you have a larger wall or deeper wall than this, you could tie the regular drainage system into the total drain. You would just remove the filter fabric from part of the area and then snap the cones together. Where do you use the total drain? You can use the total drain anywhere that the perforated pipe or aggregate collection system is used. So anywhere you have your French drain system, you can use the total drain. I talked about it, and you saw it in one of the pictures with the Blindside. The universal outlet fits to the end of the drainage system. And in that situation, what you want to try and do is slope your drainage and put it at the end of your drainage system to feed into a French drain. You can use the universal T outlet, which can go in the middle of anywhere you want in your drainage system. And that would connect to a French drain system to get it away from the building. Also, we have the TREMDrain corner guard, which would be used for the outside corners to tie in the membrane on both sides. It protects it. You would typically, not the membrane, I'm sorry, the drainage on both sides. For the installation of the corner guard, you would bend the total drain around the corner, and then put the corner guard over top of it. For the inside for inside corners, you would bend it to fit in the inside corner. The total drain for the outside corners, you would bend it to fit around the outside, and then you would cut the remay fabric, and then you would put the corner guard over that cut area in the fabric of the filter fabric. You could use the permanent seam tape that we use in our Paraseal system to tie that into the rest of your drainage system. Here is how you would install the universal T. You would cut a V in your drainage mat, about 4 inches high, 102 millimeters, by a couple inches wide, about 3. And then you would install your universal T wherever you cut that notch in your drainage system. You would tape it with duct tape, something to hold it in place before you throw the overburden back onto it, or the compaction. And then you would tape the French drain system to it. You would typically use it, in the United States we use, it's called tuck tape. It's a red tape. The outlet system just kind of fits on the end of your run of wall, of your wall section. And then you would tape it to the wall section. And then you would tape the French drain to the universal universal outlet, I'm sorry. We have more. We have the TREMDrain 3000 NW, which offers the compressive strength of the TREMDrain 2000, but with a non-woven filter fabric. That of the TREMDrain and some UV resistance. TREMDrain 8000 is a non-woven polypropylene filter fabric, but the core is made of a chemical-resistant, high-performance PVC drainage composite. TREMDrain 8500 is the same as TREMDrain 8000, but with a polymeric film to protect the waterproofing on the backside, the waterproofing membrane on the backside. We have many different options for protection courses, but down here, I don't remember the one that you have. Unfortunately, you only have one of the options for the protection courses down here, and I don't recall which one that was, but you can see the protection courses coming in over the membrane. So when they backfill onto that, the membrane is protected. So it is noon. I said I would get us out of here at noon. I was trying to fly as fast as I could through that.